Today I am going to our chapter 5 in the part 12. Exercise 5.4, question number 5. Question is there, y is equal to log of cos of e raised to x. Students, there are three functions are given in the compositions. So, I just start from these are cos e raised to x, taking up one of the composition function. And only derivative of log function I just operate. You know the formula d dx of log of base e. Students, here base e not given, so you write down first base e, and formula is there 1 by x. So this consider it is a x. So differentiation with respect to x and start the derivative. So dy by dx, here d by dx of log with cos with e raised to x base e. Now students, this dy by dx as it is. Again I am telling you, this consider it is your x. So log derivative 1 by x. So here 1 by cos e raised to x. And which derivative pending? Yes, cos e raised to x derivative is pending by chain rule. Students, here applying our chain rule. Now similarly, same I asking you, students, cos derivative, then after e raised to x is pending. So what is cos derivative? Minus sign. And d dx, e raised to x same, similarly by chain rule. So finally you know that it is how much? Minus sign by cos, internal function same. So my answer is, students, minus 10 function. These both are the merge, sine and cos. Sine by cos, it is 10 theta, and this derivative is pending, it is e raised to x itself. So students, here our this numerical question number 4 is easily finished here, and it's very simple. Now students, I going to question number 6. E raised to x square plus dash 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 e x raised to 5. Students, here total 5 functions given. So I just start our total 5 functions related. First of all, y, e raised to x square, x cube, x raised to 4, and here x raised to 5. Actually internal function are missing given. Now I start differentiation with respect to x. So dy by dx, it's very easy. dy by dx of e raised to x same is d by dx of e raised to x square same is d by dx of e raised to x cube plus d by dx of e raised to x raised to 4, and lastly e raised to x raised to 5. Students, this I one by one take their derivatives. Now what is e raised to x derivative? Yes, it is e raised to x, this one. And then after, similarly here, e raised to x square derivative. So e raised to x square, but x square derivative pending, it is 2x. Same as e raised to x cube, same as e raised to x cube, but x cube derivative pending, it is 3x square. Yes, and one more, plus e raised to x raised to 4 derivative same, but here 4x raised to 3, this also same as. And last one, plus ex raised to 5, same derivative ex raised to 5, and internal x raised to 5 is a 5 x raised to 4. This answer, students, you have done for that one. Question number 6 here. Now I going to question number 7. Now continue, students. Question number 7. 7 is the IMP question for 2 marks. Question is the root of e raised to root x. So it's very easy. Before starting, students, I just remind for your basic formula d dx of root x. It is 1 by 2 root x. Yes, and that consider this value is a x internal, and start the derivative, our basic derivative, differentiation with respect to x. So dy by dx, only and only I operate my derivative function, students. Here d by dx of root of e raised to root x. Okay, one more time repeat. What is root d dx of root x? 1 by 2 root x. So here also 1 by 2 root x is the same as, and other are as it is. So students, here this root derivative or now d dx of which derivative pending? Yes, e raised to root x by chain rule. Root over internal derivative same as. So dy by dx 1 by 2. Here can I write it is raised to half power because root. Now e raised to derivative. E raised to derivative how many? Same as, and this root x derivative is pending again by chain rule. So this function is power 1 and this function is power half. So both I merge. Dy by dx half into here e raised to root x 1 minus half. Again repeat, students. Here raised to power 1 and here raised to power half. So 1 minus half. It is as it is. And here root x derivative 1 by 2 root x. Yes. Root x derivative 1 by 2 root x. Finally over here, students, my answer is done and its basic terms finished there. So dy by dx, these are total taking 2 and 2, 1 by 4 root x same, and e raised to root x raised to 1 minus half, it is half. So your textbook answer given in this form, students, 1 by 4 root x and e raised to root x with a root, and that will be my last and final answer. For this power 1 minus half, I converting into half that, and it is a root x. Yes, so here our done. Easy. Now students, I am going to question number 8. Y is equal to log of log x. Condition given x more than 1. Here students, base e necessary. You first of all showing that if you not given in question base, you just take out it is base e. Okay. If you base e, then derivative formula is valid. You know the formula d dx of log of x base e, then it is 1 by x. Yes, that's the answer for 1 by x. So here this part I consider, students, only and only x. So differentiation with respect to x. So how many? First answer d dx of log with log x base e. This part you consider it is one of the x. So what is the first log derivative? dy by dx. It is 1 by log x and pending derivative our log x. Students, why I written the pending derivative? This log derivative not over that by this rule, and internal functions is same as by chain rule. So finally answer dy by dx here done. This 1 by log x same as, and this log x derivative is a 1 by x, and here students it's easily and happily our over sum. Same as, students, I am moving ahead. Question number 8. There now 9. Question is there cos x by log x. Here taking base e. Yes. base e, compulsory you write down first. Students, here I just take out u by v because it is a parts given. So apply here division rule. So differentiation with respect to x. Students, here just getting dy by dx, d by dx of our cos x by log x base e. So dy by dx same, and here apply here our division rule. So in denominator square, continue. Denominator d dx of numerator minus numerator d dx of denominator. Very easy and simple process, students. Now just I going to formula. So log x base is same. Denominator, what is numerator derivative? Cos x minus sin x. Same as now log x derivative 1 by x and upon log x base e whole square is as it is. Students, here done student numerical, but if you taking LCM, this LCM further taking, so that also possible answer in this way, x into minus log x base e into sin x minus cos x upon below x into log x base e whole square, and that much is my answer for question number 9. It's very easy, simple. Students, you also for more practice here taking sin, cos, tan, cot, sec, cosec upon log x. So different type numerical, 5 numerical you also shall practice calculate. Now I move ahead, question number 10. Similarly students, question 10, cos of log of e raised to x. Students, in this criteria here we assume that it is one of the our composition function log x plus e raised to x. So I start the differentiation with respect to x. So what you get first, dy by dx, d by dx of cos with log with e raised to x, but base e you necessary show out base e necessary. So dy by dx, first of all cos derivative I just asking you, then after internal function derivative. What is cos derivative? Minus sine, that same, and internal function d dx of this same as it is log x base e plus e raised to x by chain rule. Here our chain rule, students. So dy by dx minus sine of log x base e plus e raised to x. Students, now derivative for individual functions. One of the d dx of log x base e plus d dx of e raised to x by our working rule. So final answer minus sine with log x base e raised to x, and here take derivative. Log x base e derivative is a 1 by x and e raised to derivative is same, and that much is your final answer for this numerical number 10. Students, here our question 10 exercise our 5.4 is ending here. Now students, I move ahead to new topic, derivative of logarithm functions. So first of all, before starting logarithm functions, I explain you basic property for utilize in this chapter our logarithm property, and then after start our derivative. Yes students. So students, I start logarithm differentiations. So first of all, I just revise for your properties of logarithm. Here also students, every logarithm function, it is a continuous function in their domains. So logarithm functions is generally y is equal to log x to taking the function is start always positive. Yes students, always positive, not apply the 0 and not applying the negative functions. And then after I start that properties. First property is there. Every log x plus log y base is any must be both plus, then you show out the product into base A. Either base E, as you like, they are equality. Now second property, if you taking same but between is minus, base same students, so just they divided from both, means x and y both in division positions. Third property, students, third property is a IMP property, log x here power ty base A. So this y you carry forward at the outside. It means y into log x base A. Yes, y carry forward outside, and that way you just define their values. Continue. Fourth property, x raised to log of something here y, but here base x. This part is a totally x raised to students. So surely you can write down this y is a here base and log x, the base x is same. Generally students, in this criteria, you just this y and this x both are interchange their positions, and log x base x is must be every time it is 1. So your answer is only y. Property continue. Fifth one. That fifth property is in this way, log x base x, either log y base y, either log e base e, must be answer is 1. Why 1? I explain in the sixth property. It is a change the base rule property, log x to the base y. If you given, so you just translate here log x by log y. In any base means base e written, then both same. You also show out sometime log x by log y, but base 10, then also true. So this property if you apply here, sure you getting here log x by log x, base is e, surely a cutting value, answer is 1. So actually 5 and 6 property both are to relation maintained to each other. Okay, these are. You also showing this equation 1 by log y base e by log x base e, and these are the joining. It is 1 by log y to the base x. So this equation also you just show out sometime in this way, and here easily done our property number 6. Now students, here I explain one of the extra numericals. So IMP that in bold level, and then after I start our exercise. Yes. Students, now after this property, I just show out extra numerical ddx of x raised to x. Answer is that x raised to x 1 plus log x base e. This is a property. So students, you write down in your formula list, this formula is added in our formula list. So these are derivation I just going to. Suppose given question is a y, x raised to x, taking log on both sides with base e. Base e. Generally students, you know, I just going to back formula, ddx of x raised to n, ddx of a raised to x. Both formula is known. It is nx raised to n minus 1 a raised to x log a base e. Students, what is difference in this 2 and here? Look here, base is variable, power it is constant. Here base is constant, power it is variable. But here both base and power both are variable. So students, whenever you base and power are variable given, then you must be utilize logarithm functions in any derivative. So here base and power is a variable, students. That's why I start the log function taking on both sides and base e, because log function is a continuous functions. So you both type taking that, and this x is a property utilized log y base e x into log x base e, and start differentiation with respect to x. This consider u and that consider v. So here d by dx of log y base e, and here d by dx of x into, apply the product rule. Here 1 by y derivative pending. Yes, log y derivative pending, first log derivative, after that y derivative, and here utilize first d dx of second plus second d dx of first. Only I operate, students, here product rule. So you just get out the 1 by y divided by dx. X, what is log x derivative 1 by x? It is 1 by x, that plus log x base e, and here only and only 1. This x and this x is easily cancel out, students. So you get just only how many? Divided by dx is a y into 1 plus log x base e. And now, students, only this y value already I know that I am putting. So dy by dx, y put it that x raised to x 1 plus log x base e is done here, and that's our answer over for only 2 marks. So students, one more time repeat, you by heart this formula and enter in your formula list. If you are asking your extra d dx of sometime x raised to 5x in MCQ, so you students direct answer moving that it is same as x raised to 5x into 1 plus log x base e into 5, because 5x has a 5 coefficients every time. One more, if you derivative for asking x raised to minus 10x, so my answer is x raised to minus 10x. This same 1 plus log x base e into minus 10. So that is here extra. Now I students going to one more extra sum. It is IMP for exam. Y is equal to x raised to x raised to x. It is 3 marks question in IMP and many time asking in your exams. So x raised to x raised to x 3 times given, all are variable. So here I just assumptions it is something u, and then after start our sum. So first of all I assumptions that only x raised to x is a one of the variable, this value. So suppose u is equal to x raised to x, therefore what is your y? Is a x raised to u. So this part is a different and this part is different. So both part I one by one explain you. First of all here log taking, because base and power both are variable. This x is making power already outside. So log u base e x into log x base e, and start differentiation with respect to x. Students, this answer already I done here. So one more time I explain you for your better understanding. In exam also, if you this question asking, the necessary you do in these two numericals. So here dy dx of log u base e, and here first, second derivative plus second, first derivative. So what is the log u base e? It is 1 by u, and u derivative du by dx. Yes. Here log x derivative 1 by x, and that is same. And x respect to x derivative is only 1. This cancel. So what you get only du by dx. It is u into 1 plus log x base e. Students, here u value I just put out. So du by dx, this u already I know, x raised to x 1 plus log x base e, and here take out statement number 1. Up to that it is a half numerical done, students. Now I start above y is equal to x raised to u. Actual question is this, x raised to power x raised to x, but here I taking u and u derivative I separate calculate. Now I go to actual sum. It is actual calculations for your numericals. Y is equal to x raised to x raised to x. So that value is applying to, in this case, your question is a y is equal to x raised to x raised to x. This I taking x raised to u. It means this step is running here. Again take log of base e, x raised to u base e, and start differentiations. And this y you take out the outside. So log y base e, u into log x base e, differentiation with respect to x, and apply their basic derivative. In this derivative you must be utilize this one, du by dx. So here dy dx of log y base e, here first, second derivative plus second, first derivative. Correct? Yes. So what the log y derivative? 1 by y, and y derivative is with respect to x, it is dy by dx, and dy by dx is my target. Here u, log x derivative is 1 by x, and plus of log x base e. What is the u derivative for respect to x? Du by dx, this one? Yes, students, this value already I first calculate from here. Means from 1 I just apply there x raised to x into 1 plus log x base e from 1. Now this u just you submit it. What is your u? X raised to x. So 1 by y dy by dx. Here x raised to x by x, and here same as x raised to x log x base e, and 1 plus log x base e is also same. Students, here just to take out common, and other just y carry forward right side, then you get one more answer. So check out this totally, dy by dx is a y, and x raised to x is common, but the remaining 1 upon x plus log x base e into 1 plus log x base e, and this y is also you submitted in your questions. Y is also x raised to x raised to x, and here x raised to x raised to x, x raised to x, and this same is, and here our answer is done. you getting here students 3 marks. Now students, after this ending our extra numericals x raised to x and one of the x raised to x done here. And further explanation students, I just explain you in the next part. In the derivative related our exercise continue 5.5. So bye bye, see you.